This video is on Chapter 2, the benchmark model of the economy. It has a lot of microeconomics in it, and I hope you will get a glimpse of that. So, a consumer chooses combinations of commodities X and Y. So the blue curve is an indifference curve. I'm quite sure you learned about indifference curves in economics 1 and 2. So everywhere on the blue curve, the consumer has the same level of utility, consuming commodities X and Y. And the consumer has an infinite number of indifference curves, so the higher the curve means the more of X and Y the consumer can consume. So if we have three curves, then the green one will be the highest level of utility because it's the furthest away from the origin of the box, of the graph. The slope of the indifference curve, you have to know the name of the slope of the indifference curve, namely the marginal rate of substitution. So we can draw a straight line, marginal rate of substitution at the tangency point is the slope of the indifference curve. Now the red line in this graph is the budget constraint of the consumer. So the consumer has a specific income and can only spend that much. So there's a limit to what the consumer can consume. With this budget, she cannot reach the green indifference curve, even though she would like to reach the green one. So the consumer's budget constraint has a slope of the ratio of the prices of goods X and Y. And the equilibrium point will be at point E, where the slopes of the two are the same. So the slope of the indifference curve, which is the marginal rate of substitution, will be equal to the slopes of the budget constraint, which is the ratio of price X to price Y. So the consumer is in equilibrium at point E, maximizes utility at point E, we say, where the slope of the two curves are the same. So we could have two consumers. So let's say that we had consumer Ann just now, but we could also have consumer Dan there's a very similar graph. And I mean, we learned to draw a graph like the one on the left, but why couldn't we just flip it around and draw it like the one on the right? So let's draw Dan's curve upside down. The principle is the same. So Dan has indifference curves, and this green indifference curve is also the furthest away from the origin and shows the highest level of utility. And the budget constraint is the red line. So you can see that the slopes of the budget constraints are the same. Why would that be? Because prices in the economy are the same for everyone. So the prices that Anne has to pay at the supermarket is the same as the prices that Dan has to pay at the supermarket. So hence the slopes of the price ratios are the same. So the first condition that we have for the benchmark model to work is that the marginal rate of substitution of all the consumers must be the same. So the marginal rate of substitution at equilibrium for Anne is equal to the price ratio, but the marginal rate of substitution for Dan is also equal to the price ratio because prices are given in the market. And so the market with prices working will have all consumers in equilibrium at the same time. So if we now would push these two graphs together, so let's say we have a specific amount of X and an amount of Y that we want to share between Anne and Dan. So you can see that Anne's graph is still the same and Dan's graph is still the same. We've just moved them together to form a box. Now the horizontal line on the box is the total amount of X available in the economy. and the vertical height of the box is the total amount of Y available in the economy. So, and they have to share between the two. Now, can you see that I've drawn the curves such that they touch each other, but each consumer has an infinite number of indifference curves. So I've just picked 3 for each one, and I have manipulated the graph such that at least there are 2 tangency points at the red dots. Now, at the yellow dot, just look at the yellow dot. At the yellow dot, we say that we don't have Pareto optimality. Now, I haven't given the definition of Pareto optimality. Yellow is not Pareto optimal for the simple reason that we can improve either an or Dan situation by moving to one of the red dots. If we would move from yellow to the top red dot, then we would move on to Ann's highest indifference curve. So at yellow we are at Ann's second indifference curve, and we're also at Dan's second indifference curve. But if we would move to red, we move on one of Dan's curves, but we move to a higher curve for Ann. Similarly, if we move from yellow to the bottom red, we stay on one of Ann's curves, so we don't harm her at all by moving from yellow to red, but we are improving Dan's situation, because from yellow to the bottom red, we move to a higher indifference curve, the green one, for Dan, which is his best of the 3. So moving from yellow to red to either one of the reds means we improve at least one of the consumer's situation, and that means yellow isn't a Pareto optimum. So a Pareto optimum is a situation where you cannot improve upon any one of the consumer situations without harming one of the others. Okay, so you can also see that the slope of the marginal rate of substitution, the slopes of the indifference curves at yellow are not the same. The one slope for Ann is quite vertical, and the slope for Dan is flat. So the equilibrium condition that we have on the right doesn't hold, because the marginal rates of substitution are not the same. So this is the same graph as you have in figure 2.1 in the textbook. It's called the Edgeworth box. So we make a box and we show. So it's important to know what's on the axis. So on the vertical axis we have commodity Y, and on the horizontal we have commodity X. And then the two consumers, person A and person B, have to exchange until they are happy. They will also always exchange onto the red line, because the red line combines points like R, T, and S, where the marginal rates of substitution of the two are the same. So only at the red line we have Pareto optima. If you move off the line, you will harm at least one of the two. So R is a Pareto optimal point, T is a Pareto optimal point, and S. So that's the thing, we don't only have one Pareto optimal point, we could have many of them. There are an infinite number of Pareto optimal points. But if we let the market work, then the system will move onto those onto the red line automatically. Now the second condition for efficiency in the benchmark model as concerns production. Now figure 2.2 is also an Edgeworth box, but with a difference. What do we have now? You remember earlier we had goods X and Y. Now we have factor K for capital and factor L. So now we produce the X and the Y. In the previous Edgeworth box, two consumers were exchanging goods between each other. But now we're busy producing the goods, so it's completely another idea, but we can also use the Edgeworth box to show this idea. So on the left bottom origin, we have the origin for production of X, and on the top right origin we have the production of Y. So now we don't talk of indifference curve, so this indifference curve is now, we call this an isoquant. So to produce X, the further away you go from the origin, you produce more and more of X. You can see that we moving from left to right means we use more labor to produce X and more capital to produce X. So the further away from the origin again, the more is produced. While if we move from the top right down, then this is a small amount of a production, that's more of good Y, and this is the most of good Y, using capital and labor. So this, you can think of two firms who work in the same town and they have to share labor and capital. If one firm employs the labor, then the labor is not available for the other firm. Similar, if we have a fixed stock of capital and one firm uses the machines, then those machines are not available for the other firm. So they share factors of production, and they again are in equilibrium on the connection line of all the optimal points. Now the slope of the an indifference curve was marginal rate of substitution, but now we say that the slope of the isoquant is the marginal rate of technical substitution. So again, the light blue line shows all the optimal combinations of production, of using factors of production, and everywhere on the light blue line, the marginal rate of technical substitution for producing X is equal to the marginal rate of technical substitution for producing Y. Now we can use this. So the light blue line shows different combinations of X and Y produced. So the further away from the origin from X, the more we produce of X, and the further away from the origin from Y, the more we produce of Y. So we can draw this graph in another in another graph with the different dimensions. So the dimensions in this graph shows the total capital and labor, but we want to have it in the form of total production. So then we get the the production possibility curve. So I will continue with the production possibility curve in the next video on chapter 2, because YouTube wouldn't let me upload videos longer than 15 minutes. So I'll see you just now in the next video.